chi-squared table, and we can see straight away that it's this. If we keep reading down, you can see that we're asked to find the chi-squared statistic, and you can also see that we have a two-way table, one which is the information about where people studied, and one is the information about the time in which they studied. So it's a two-way table, chi-squared, which is a test for independence. So the first thing we have to do is to write down the null and the alternate hypothesis. And when you're doing a chi-squared table or a chi-squared test for independence, it is always that the null hypothesis is the two variables. So we have in this question the study time and the environment. So I'm going to write study time and environment are independent. So it's always the independent for the null hypothesis. Whoops, independent. And then for the alternate hypothesis, it's going to be exactly the same things, but this time it is dependent. And in a test, obviously make sure you write it out in full and don't do the dots as I've done here. The next question is to write down the degrees of freedom. So the degrees of freedom, when you're working them out on a two-way table, is always the number of rows minus 1 times by the number of columns minus 1. So you're going to subtract 1 and then times them together. So we have 1, 2, 3 columns. So minus 1 is 2. And then we have 1, 2, 3 rows, minus 1 is 2. And therefore my degrees of freedom are 4. And then for the last part of this question, I'm asked to work out the chi-squared statistic, the p-value, and then to state the conclusion of the graph. So to do that, we need to go to our GDC, and I'm going to first of all set up a matrix. So I'm just going to input the data into my matrix, and you can see I've already put the data into here. So we don't include any totals. If there was any, there wasn't on this question, but it's all been input. Then we can go to statistics. We come across to tests, and we want to do the chi-squared test for independence, which is this one here. So option C. The observed values are what we've just typed into matrix A. They're going to put the expected values for us into B. We don't need to find them. And then we can calculate, and we can confirm there that our degree of freedom is 4 as well. So we can write down that the chi-squared statistic is equal to 10.9 to 3 significant figures. And the p-value is equal to, and again to 3 significant figures, it's 0.281. So 0.281. And then we need to come up with a conclusion. So for this one, the p-value is equivalent to 28.1%. Now that is much bigger. Oh, hold on, I've written that wrong, sorry. The p-value there, I've missed a 0 off, is 0.0281 to 3 significant figures, which is roughly equivalent to 2.81%. And 2.81% is less than 5%, and therefore 2.81 is less than 5, which is my significance level, and that means that we reject the null hypothesis since the p-value is smaller than the significance value. And if you wanted to, you could also draw that into a little diagram. So we have our 5% significance value, as is 2.81, so it's over this side. The significance value is what decides whether we want the null or the alternate. And you can see there we're definitely in the alternate side.